Pop quiz time, my friends. What are supercapacitors? Nope, not an elite group of caped crusading super nerds. But that does sound pretty awesome. Maybe you've heard the words SuperCap, GoldCap, Ultracapacitor. Again, totally not geeky superhero names, but they absolutely should be. And maybe my next Halloween costume as well. Get a couple of assorted parts from Mauser, a gold cape, and yeah. Okay, sorry. No, what we are actually talking about are high cap capacitors. Alright, that's great, but what can they do? Why would I need them? And how can they help? Well, my friends, you are in luck. I've got just the expert to illuminate the electrifying ways, wait, that sounds bad, of supercapacitors. Hi, I'm Amelia Dalton, host of Chalk Talk. Today, my guest is Shawn Hansen from AVX, and we're getting into the what, the where, and the how of supercaps. And no supervillains were harmed in this episode. Let's go. And before we get started, don't forget to click that link. There you can find out more information about AVX's supercapacitors. Hi, Shawn. Thank you so much for joining me today.
Thank you for having me.
Okay, so if I'm thinking about choosing a capacitor, what do I need to know? And what do I need to be thinking about?
When it comes to supercapacitors, there's some key things we want to go into and understand before selecting what type of supercapacitor to select. The most important parameter that we really need to understand is what the application operating temperature range is going to be. And this is because the supercapacitors all are using some form of internal liquid electrolyte, and those electrolytes have varying parameters of either freeze point or boiling point. And so the operating temperature range will dictate which electrolyte system is best suited towards doing that. So after we do that, then we really want to know more information on the application. Different applications will focus on the importance of equivalent series resistance or leakage current as another very important parameter for how the application utilizes a supercapacitor. I really want to know what the operating voltage is going to be within the circuit as well. We may have to put more than one supercapacitor in series to put that into what we call modules, or we also have technologies that allow for pre-built modules that allow for those supercapacitors to have higher voltage ratings within the AVX systems. Obviously, capacitance is going to be the size of the capacitor or the amount of energy stored for the application. We'll need to determine that. We'll need to determine the lifetime expectations of how long the supercapacitor needs to last for in this circuit or application. Many people will have a 5-year, a 10-year, a 20-year warranty on their product, and we've got to design the supercapacitor to last for that long. All supercapacitors will age with time, but we can control that aging rate. And that aging rate is dictated by the application voltage and the operating temperature. So we have those parameters already identified, and we can use that to determine how to select which supercapacitor and how many parts we need to put in series in order to allow for the voltage to meet those lifetime expectations. The last parameter we really want to talk about is cost. Does your circuit or your design have the ability to include the cost of a supercapacitor? It's slightly higher than batteries, but it has another different function of batteries, and we'll get into that a little bit later on, what we want to do to determine whether a battery is the best application or a supercapacitor or a combination of the two.
So what does AVX have to offer in this area?
AVX, we've been building supercapacitors in the R&D lab since about 1997. AVX was the first company to develop and introduce a low ESR supercapacitor back in 97. We released that product in 99, 2000 timeframe. That is our BestCap series. And that product line has been around since then, has been very successful. It's a very niche product line. It's got a very limited temperature operating range, but it is really the first low ESR supercap that could handle high current pulses. Since that time in 2010, we started research and development on organic-based electrolyte systems, and we have since released both cylindrical and soon to be announced prismatic series supercapacitors in organic-based systems. So this is exciting for us. We also have been focusing on module development and building modules out of multiple supercapacitors in series in order to offer higher voltage type application solutions. The BestCap series, our oldest series that we introduced, it uses an aqueous-based or a water-based electrolyte system. Now this system is different than the organics in that it has a much lower ESR per farad range than the organic systems by a significant amount. We can offer a 1 farad capacitor rated at 5.5 volts with an ESR of only 25 milliohms. This is extremely low, allowing very, very high current for this. There are specific applications where this is very desirable. However, that technology is very expensive to manufacture compared to the cylindrical series. So the BestCap is very niche, very just certain applications require that. Most of our circuit applications are going to the cylindrical, and that's why we really focused on getting the cylindrical manufacturer to a quality level that AVX can stand behind.
Okay, so if I'm thinking in terms of cylindrical, what do you have for me there?
So with the cylindrical series, this is our SCC and SCM series of cylindrical modules. We've introduced those in August of last year, and they are our fastest growing market segment of all capacitors in AVX at this point in time. We have the highest number of new customers going and the highest number of design-ins by product line by far of all the other areas of AVX. We offer the SCM series of modules. Those are standard-based modules that we offer in 2 and 3 part series configurations. We offer these in both balanced and unbalanced versions. And I get the question, why do we offer in unbalanced and balanced versions? And it goes back to which is more important, ESR or leakage current. When we balance these with a passive balance network on our modules, we have to put a resistor in parallel with each capacitor that is in series. This allows for an equal division of voltage across and keeps the voltage the same on each part. This allows us to operate up to close to rated voltage, but then the resistors are larger than what the leakage current of the part is, and we have to do that in order for the balancing to work, but that increases the leakage current of the part. And if you're trying to put this part in parallel with a battery, leakage current is the last thing you want because that self-drains the battery. So we offer an unbalanced version in which we put the 2 parts without those resistors that keeps the leakage current as the lowest of the 2 capacitors that are put in series. That limits the leakage current, so we always are getting the best of the best there. But then the concern is what happens when we put that voltage on 5 volts across this part that is unbalanced? How do we control the voltage across there? And the answer is AVX has developed a technology that we take and measure the capacitance, the ESR, and the leakage current of all of the parts 100% at electrical test. We then have a software program that allows us to choose those parts that are like very, very close with ESR, cap, and leakage current, and we bin the parts based off of those parameter values so they're like parts. Then we build the modules out of those like parts. When we do that, and I think our team has already developed a white paper, it's available on the website, we have shown that our SCM series modules in unbalanced format, if you're operating at 4.5 volts or less, they actually self-balance. The balancing voltage on both parts comes together. The difference between the voltage on the parts after 1,000 hours is down to 0.1 volts or less differential on the parts. So this is very, very good news because we can now keep the leakage current low for battery applications and provide you a higher voltage part that will last and last and last, similar to what the standalone series of SuperCaps do. If these parts were to go out of balance, you would see very, very short lifetimes. And we see that in runaway. We've done that with over voltage and with cells built without matched parts. We see customers a lot of times, they think it's a lot cheaper to buy 2 individual parts than it is to buy one of our modules. And they put the parts themselves on the board. They have lifetime issues or they have to put the balancing on there. With our parts, it's a little bit more expensive to buy the module completed, but please understand, we've got over $1 million worth of test equipment that matches those 2 parts together. And that is done at the factory, and we match those cores, and then we're providing you a product that you can stand behind and make sure that your product lasts out there that's needed. So we've expanded these modules from 2 parts out to 3 parts now. So we're offering all the way up to 9 volts in a balanced version module with 3 parts in series. So we've got a wide range of SCM product available. We're also working on releasing new larger modules. We've got a module out there now that's out on the website that is 18 3,000 farad parts in series. This uses an active balance, much more sophisticated balancing network to keep leakage current low. And this gives us 48 volt operation with 165 farads of capacitance. Guys, this is a lot of energy. This is being used in automotive, robotics, and other different very high energy applications. We even have a guy building a portable welder with this product line that he can charge up at his truck, take this out to an offsite location, and he can weld with the amount of current that this module will be able to produce. So this is new exciting stuff, and we're really building up our custom module into the future. It's not quite ready yet, but we have great plans, and we're putting in the test equipment and the design team and to really expand on our module development going into the future.
So Shawn, what kind of new things are you working on? What's the next generation look like?
So in the next generation, I kind of touched on this briefly. We're looking at prismatic series, and prismatic is a flat form factor of the organic-based electrolyte system. One of the things that the Cylindrical series offers, we use an acetyl nitrile electrolyte system. This has a temperature range from about -40 to plus 85 degrees Celsius. The boiling point is a little over 85 degrees Celsius, and the freeze point is -41. So that limits where we can really operate that capacitor in. We have requirements that want to go beyond that temperature range. So we really focused on the development with a new electrolyte system called propylene carbonate that has a freeze point of -56 and a boiling point of 240 degrees C. This now extends that operating temperature range much greater than what the ACN. Unfortunately, we still have to use a salt load within the electrolyte system, and that salt load will dictate what voltage we can apply at what temperature. With all supercapacitors, the electrolyte system, the amount of voltage that can be applied is a function of temperature. As the temperature goes up, it takes less and less voltage to actually start breaking down the electrolyte system. So unlike the other capacitors, MLCC, tantalum, aluminum electrolytics, that type of product line, our voltage is a function of temperature. And we really need to understand that when designing this into the circuit. So with the SCC, the cylindrical, and the ACN, we can put 2.7 volts per cell. We've got a new electrolyte system of 3 volts per cell being released now that allows for that to operate up to about 65 degrees C at those rated voltages. We can go up to 85 degrees C, but we have to derate down to approximately 2.3 volts per cell or 2.5 volts per cell in the 3 volt system. This allows us to operate up at 85 degrees C. Caps that we generate and build at AVX, most of them are being able to handle over 2,000 to 3,000 hours of operation at that rated voltage of 2.3 volts per cell at 85 degrees C. I believe this leads the industry in all the reliability testing by far. We know that this still is a limiting factor for some of this. So with the propylene carbonate system, the salt load there, we can actually operate all the way up to 90 degrees C before we start breaking the electrolyte down. So within the electrolyte system of propylene carbonate, we can now operate between -55 and plus 90 degrees C. Storage temperatures, we can actually run this storage on the propylene carbonate based system all the way up to 105 degrees C without degradation on the capacitors. This is the highest storage temperature and the highest operating temperature of all supercaps that we're aware of in the market at this point in time. So the new system that will be released, and it will be officially released come first quarter of next year, will be called PrismaCap. We do have some limited production and some limited sampling capabilities at this point in time, but we'll have full mass production capabilities ready to go by the end of first quarter of next year. This is an exciting new product line for us. We're really looking forward to getting this out in the market. The customers are really liking this type of product.
That sounds great, Shawn, but really, how do these all stack up?
We try to provide information on our website as well as with our application engineers at AVX. We do a lot of training with the application engineers at Mauser directly, and we try to get the information out there to allow you to help you choose which supercapacitor technology.
Okay, first, let's talk about operating temperature range.
For the BestCap, we have a defined temperature range of about -20 to about +70 degrees C for lifetime qualification. But for actual operating, we really don't want to design a BestCap in on anything above 55 degrees C max operating temperature. The capacitor will age very, very quickly above 55 degrees C. We'll qual test these to 1,000 hours at 70 degrees C, which they'll last. But if you're looking for something for 10 years operation, we can do that at 55 degrees C. The capacitor is solid. And again, because it's water-based, we add a little bit of acid into it to reduce the freeze point, but really -20 is right on the low end. We also see a very high increase in ESR of this aqueous-based electrolyte system at cold temperatures. So from a temperature standpoint, BestCap -20 to +55 for operating temperature range. If you need wider than that, then the SEC series from -40 to +85. And if you need wider than that, then we're going to be offering the PrismaCap series from -55 to +90.
And what about storage temperature range?
Storage temperature range, PrismaCap is again the leader in this. It'll go all the way up to 105 degrees C and no problem storing as cold as you want. The organic-based electrolytes, when they freeze, they go into more of a gel state and they actually shrink, so they do not damage the capacitor when they freeze. The BestCap, however, if you go below the freeze point there, we can actually have that turn into ice. It expands and it actually damages the capacitor. So BestCap's storage temperature is the least. Then we can go a little bit higher with the SEC and much higher with the PrismaCap series.
Okay, so what about operating voltage?
The BestCap series, even though we can only operate at about 0.6 volts per cell with the aqueous-based electrolyte system, we can stack these parts in series and get voltages all the way up to 20 volts internally without the need for external balancing. This allows us to offer the supercapacitors and BestCap up to 20 volts. The higher voltage is a requirement. That's great. However, the BestCap, the max capacitance is only 1 farad. So we're really talking on the lower end of the SuperCap range. When we get into the SCC series, now from a operating voltage, we can operate at 2.7. We've got some systems now that'll go to 3, and we've got stuff in R&D that's going out to 3.3 in the future. These are exciting things going on in that, but still 2.7. With the SuperCaps, lifetime can have some rule of thumb parameters assigned to it. For every 10 degrees C of higher operating temperature, lifetime will divide by 2. Or if we reverse that, if you can lower the operating temperature by 10 degrees C, lifetime will double. With the voltage, if we apply about 0.2 volts per cell less per cap, that also will double the lifetime of the supercapacitor. So even though they're rated at 2.7, if you can design the circuit to operate at 2.5 or 2.3 or 2.1, we can really extend the lifetime of these supercapacitors. Again, dictated on what you need. If you're building a printer that has a 90-day warranty, you may not want that. If you're designing something on a solar panel that's got a 20-year warranty, yeah, we need to really look at the lifetime calculations. It's very important. We get to PrismaCap. PrismaCap's got that wider temperature range, but there's a offset. We can't get quite as much voltage per cell there. We're really operating at about 2.1 volts per cell on the propylene carbonate system at 60 degrees C rather than the 2.7 on the acetyl-nitrile. There's some give and takes always within the supercapacitors, within the parameters of the materials that we have to work with. So the voltages, again, we can make the modules and we can actually stack parts in series to increase voltage. And then we're also working on some new exciting things with a power management IC that will work in conjunction with these lower voltage supercapacitors. This new power management IC that we're developing, we actually have that'll have a boost buck converter built into the IC, and that will allow us to charge the capacitor with a integrated thermistor. It will reduce the voltage on the capacitor as the temperature goes up, but it will boost the output voltage to a constant output voltage. In reality, we're going to be able to have a capacitor that very much looks like a battery in terms of its operation, where the voltage will be constant on the output side. And to a traditional supercapacitor, as you use the energy out of the capacitor, the voltage will decrease as the current is drawn out of the capacitor. But with this power management IC, we'll give a constant voltage output. So there's some really interesting things we're working with there. We're also offering the modules in 12 volt, 24 volt, 48 volt configurations. We've even released a new 120 volt module, and some of these are upwards of hundreds of farads in capacitance. And the SCC series, we can offer up to 3,000 farads in capacitors, and with the new PrismaCap series, we'll be offering up to 500 farads in capacitance.
Now, Shawn, is there a minimum height requirement here?
The BestCap, it's in a prismatic form factor as well, in a stainless steel can. The minimum height that we can get down to is 2.1 millimeters for a 4.5 volt device. And as we increase the voltage rating on the BestCap series, the height of the part increases. When we talk about a 15 volt part, we're talking about something in the 6 millimeter height range. 4.5 volts, we're down in the 2.1 millimeter range. And this is because we internally stack the capacitors in series in the part. So as voltage goes up, height goes up. Now with the cylindricals, we're in a round can or cylindrical can, and we can go as low as 6.3 millimeters in diameter. And then we have product line clear out to 60 millimeters in diameter. This allows from 1 farad out to 3,000 farads. Can sizes can go from 8 millimeters, 10 millimeters tall, all the way up to somewhere in the 155 millimeter range. So think of something the size of a small thimble to as large as a beer can. So much, much wider range within the size of the cylindrical product. With the PrismaCap, we can build parts as thin as a 0.5 millimeter. So this gives us now something that doesn't necessarily need to be mounted to a board. It can be part of your packaging in your product, or something that is very, very thin within the product itself. This is very exciting for low profile projects, and we can make the product is XY footprint anywhere from about 25 by 25 millimeters out to 85 by 155 millimeters. The new manufacturing plant, all of the sizes are literally programmable by software, and everything is cut out by laser. So we can custom design and custom build parts to size very, very easily if the need arises.
All right, Shawn, let's talk about a really important part of all of this, expected lifetime.
We touched a little bit on this. The lifetime expectations on the BestCap, our qual data is 1,000 hours at 70 degrees C. We have field operation data where we show that it's been in the field for 10 years at 55 degrees C constant in gas meter, underground meter type systems. The parts are very, very stable there. It's 70 degrees C, 1,000 hours, which is literally less than 3 months, guys. So we've got to understand that lifetime, as we cross over that 55 degrees C, lifetime becomes shorter and shorter and shorter very, very quickly. With the SCC product line, all of our 70 degree testing and rated voltage, again, we rate the 2.7 at 65 degrees C, but if we do a 70 degrees C test, we'll get about 2,400 hours on average for lifetime. That's above rated. We show that in our reliability testing at 85 degrees C at 2.3 volts, we're getting closer to 3,000 hours of lifetime. And at 65 degrees C, we're getting closer to 6,000 hours of lifetime on that product line. So we can go much higher temperatures, much longer. If we reduce the voltage a little bit, we can go much, much longer and keep the change in ESR and the change in capacitance well within check. PrismaCap, this is the much longer lifetime. If we keep the voltages at the rated voltages that we've assigned for this product, we've got 6,000 hours of operation at 90 degrees C and still within specification. So much longer product lifetime within the propylene carbonate based systems. Again, so depending on the application, we can really adjust and choose which technology best suits the application that you're trying to do.
Well, I think I'm ready to get started. Where should I go for more information about supercapacitors?
I think the best place to go is to the Mauser website or the AVX website. We have our SuperCap information there. We have a lot of information available on those websites. We also have application engineers worldwide available for you through either Mauser or through AVX, and more than happy to come out and visit or talk on the phone and try to help you understand what your application is and help you choose which supercapacitor technology best fits that application and which one to choose to really get you going. Mauser.com offers a variety of values available off their website. 1s, 2s quantities, 5 quantity, whatever you need there. They're very, very good at keeping inventory on all product line that we offer, except PrismaCap, which will be released sometime in the near future, first quarter of next year.
Very cool. Well, I think that's all I have time for today. Thank you so much for joining me, Shawn.
No problem. Appreciate it very much.
And before we go, you didn't forget to click that link, did you? There you can find out even more information about supercapacitors from AVX. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, check out the Chalk Talk section of EE Journal or head on over to YouTube, keyword EE Journal.